Hello, 8th grade math students. Mr. Lawrence here, and this is going to be part 1 of Digits 7-1. Okay, this is part 1. We'll do part 2 tomorrow. I am assigning Digits 7-1 tonight for homework, but I can understand if you don't finish 100% of it until you've seen the entire video. There's just so much material here. I don't think you can do it in one day and be as effective as you could over 2. So you're going to want to take some notes. I'm going to pause the video and talk about things, but let's get started.
Any set of ordered pairs is called a relation. The input values are the x-coordinates. The output values are the y-coordinates.
So this should be review. You should be going ahead and copying this down. Okay, you've got the ordered pairs, x before y. Input is always x, output is always y. All right, there you go. And they took the x values, the first one in each ordered pair, x, and they put it in the input column. And then they put the outputs, the y coordinates, in the output column.
A mapping diagram describes a relationship by linking the input values to the corresponding output values using arrows.
So in this one, this is not a mapping diagram. This is an input-output table, which you should be familiar with. If you put 2 into the relation, you get 16 out. If you put 1 into the relation, you get 8 out. They're going to show you a mapping diagram, which is going to look just a little bit different, and it's going to come up right about now. So this is a mapping diagram, and it's very similar to the input-output table, only it's not actually a table. There's a set of the input, a set of the output, and then an arrow links them together. Okay? So this is just definition stuff. They're going to be using these. All right. They want you to match each set of ordered pairs with its mapping diagram. Well, here's the first set of ordered pairs. 1 has to be going to -1. Well, let's see. 1 is going to 0 in this one. Well, that's not it. 1 is going to 2. Nope, that's not it. 1 is going to -1. That's a possibility. 1 is also going to 1. See how 1 is going to 1? Yep, it must be this one. There we go. Here we have 0 going to 1. Yeah, 0 goes to 1, but 0 goes to 1 over here as well. 1 is going to 2. Well, 1 is not going to 2 in this first one. 1 is going to 2 on the second one. All right. And then the third one by default must be here, but we can check. -2 is going to 3. Yep, -2 and 3 are an ordered pair. 0 is going to 1. 1's going to 0. There you go. Okay. So copy this one down in your notes and see if you can list the set of ordered pairs. All right? The set of ordered pairs. I'm going to show you the sets of ordered pairs here so that you can make sure you did it correctly. So I believe my first ordered pair might be 2, 4. And then I'm going to have -2, 4. I will also have 5 to 25, 525 at that point, and -5 to 25. Okay, those are the ordered pairs for that mapping diagram. Okay, so now let's see where we're going to next. All right, they want to know if these relations are functions. So we better go back here and we better define a function. Okay, a function is a relation such that no input goes to more than one output. Okay, no input can go to more than one output. I teach my algebra students, you can't use this as a reason on a test, but it's good for making sense. Input are like people, okay, and output are like restaurants. Okay, so let's take a look at this mapping diagram. Where is 1 going? You know, we can pretend that 1 is Carter. 1 is Carter, okay? And Carter is going to the Olive Garden, right? Okay, and 2 is going to be Hope, and Hope, she's going to Applebee's. Okay, Applebee's. All right, and then 3 is going to be Tino, and Tino is going to Mickey D's. Okay, is this possible? Is this functional? Is it possible for Carter to go to Olive Garden at the same time Hope is going to Applebee's and Tino's going to McDonald's? Yes, this is a function. Function. Definitely a function. Okay? If we look at this input-output table, here's my inputs, right? My inputs are my x values, input, and then y's are my outputs. Is there any input going to more than one output? Or you can give these people names, or these numbers names. You know, here's Aiden, okay, and then here's Elizabeth, and here is Alice, and here are the restaurants they're going to, maybe Burger King. So Aiden's going to Burger King. Alice is going to the Outback. Okay. And then, oh no, that's Elizabeth going to the Outback. Sorry. And this is Ellis down here, and Ellis is going to, oh, let's say KFC. You see, they can't be going to the same restaurant because they're different numbers. So this is also a function. Okay. Is it possible to have a situation like this? If this is my input, by the way, in algebra, you're going to call the input the domain. Okay. And here's my output, and that'll be called the range, okay, at some point in the future. And let's make the, you know what, I want to save that. Hold on one second. I won't bore you with my details. Okay, I'm back. So, look at this situation here. I've got this input and this output. It's a mapping, right? And I've got 2. Who do I want 2 to be? 2 is going to be Taylor. How about that? Taylor. Okay, it's going to be Taylor. Now, we'll never use Taylor in an argument on a test, but it's just to help you build understanding. So Taylor is the input, the 2. Problem is, Taylor told his best friend that he would meet him at McDonald's at 6 o'clock. But Taylor's mom says, we have dinner plans at Panini's. Is it possible for Taylor to go to McDonald's and Panini's at the same time? No, of course not. This is not a function. It's not a function. It's not functional. Taylor cannot do that. It's not a function. I shouldn't put not a functional. Sorry about that. All right, it's not a function. We call it only a relation. It's simply just a plain old relation, depending on what they want you to identify. Okay? All right. But let's look at this situation, and let's have 3 be Paige, okay, and 4 is going to be Emma, okay, and this is going to be Rallies, even though we don't have any Rallies around here. All right, is it possible for Paige to show up at Rallies and Emma to show up at Rallies? I mean, they might have gone together. That's a possibility, you know, so that, hey, you invite a friend and one of them invited the other. Or they could have just both ended up there at the same time, right? So Paige goes to Rallies, Emma sees her at Rallies. Oh, hi, Paige, how you doing? You know, that kind of stuff, all right? This is functional. This is a function because no input is going to more than one output. So to be a function, no input can go to more than one output. Have you written that down? I've said it a couple times. All right, oops, I don't know what happened there. Okay, so see this ordered pair, these ordered pairs here, 0, 1, 1, 4, 2, 5, 3, 7. Okay, remember the x-coordinate is the input and the y-coordinate is the output. Is there any input going to more than one output for A? Well, where's 0 going? To 1. Only to 1. That's like Paige going to Rallies. Boom. Good. This 1 here is only going to 4. It's not going anywhere else. This is like Austin going to Burger King. Okay, so far so good. 2 going to 5. Well, that's like Aaron going to KFC. All right. And 3, I don't know, who haven't I mentioned yet? Justin going to Olive Garden. Is it possible for those 4 people to go to those 4 different restaurants at the same time? Sure it is. This is a function. Okay, let's take a look at B. B has -2 going to 0, -1 going to 0, 0 going to 0, 1 going to 0. So we've got 4 inputs going to the same output. Is that a function? Well, let's name the 4 people. Let's see here. We've got Toran and Marissa and Wayne and Nadim. And look at this. They're all going to the Edwards School cafeteria. Yeah, I know it's not really a restaurant, but technically it is. All right. Is that possible at all? Yeah, they do it every day that we're allowed to be in school, right? They go to the cafeteria at the same time. This is a function. Okay. Here we have 0 going to -1 and 0 going to 3. I don't even need to look at the rest of it. This is not a function because who do you want this to be? Maybe this is Chloe. This 0 is Chloe. Okay? Chloe's trying to go to McDonald's and to Burger King at the same time. It is not a function. All right. No, I'm good. All right. I think that's it for the video today. That's all I wanted to accomplish today. We'll watch part 2 tomorrow, which will cover parts 3 and 4 of 7-1. All right, Mr. Lawrence signing off. Have a good day, everybody.